Okay, here we are, problem 6, A and B. Both of these problems require that we use the substitution method, and so let's go over it really quickly. Substitution method is essentially saying you're going to solve for one of your variables in one of your equations. You're going to sub that into the other equation, solve for one of your variables, and then back sub. That's a very complicated way of just saying, notice here y is already solved for. Y is equal to 2x minus 13. So everywhere we see a y in our other equation, like right here, you're going to plug in the 2x minus 13. We did something similar to this, almost like composition, but here it's called solving a system of equations. And so here we have negative 4x minus 7 equals 9, open parentheses, 2x minus 13, because I replaced the y with what y was equal to. Of course, then you go through your classic linear equation. It's a little bit bigger number. Okay, then we got to move our variables on one side, so I'm going to take them over here, move my constants to the other side. I get negative 22x equals negative 110. Divide by negative 22, and I get x is equal to 5. Be careful, it's very tempting to just end your problem here, but remember this is only 50% of our answer. We still need to get the y that it's associated with. So the way we do that is we back sub into either one of the equations. It really, frankly, doesn't matter, but notice here we already have y equals 2. So if I back sub this into my original first equation, we get y equals 2 times 5 minus 13. Y equals 10 minus 13, and we get y equals negative 3. So we end with, it's no longer a mystery. The y value that's associated with the x is negative 3. So this is in fact a consistent system that does in fact collide in time and space at 5 negative 3. They're linear systems, and so that's why they intersect. Let's look at B. Still, we're dealing with linear. The only difference is here is that none of my variables are already isolated. So that means it's up to us to isolate one of our variables. I'm going to go ahead because the y in the first equation doesn't have a numerical coefficient. It just has the negative 1, which is pretty easy. I'm going to solve for y here. Negative y equals negative 3x plus 8 divided by negative 1. So I get y equals 3x minus 8. So every place I have a y equals in my second equation, this guy, I'm going to replace it with 3x minus 8. So here's my y. I'm going to replace it with the 3x minus 8. So I get 6x minus 2, open parentheses, 3x minus 8 equals 10. I get 6x minus 6x plus 16, sorry, equals 10. Notice something really interesting here. 6x minus 6x would just completely cancel out my x's, and so that leaves me with 16 equals 10, but that's not true. 16 doesn't equal 10. That's a false statement. Anytime this happens, what this means is you, in fact, have no solution. No solution. This really what it means in plain English is that if I would have graphed these in y equals mx plus b using one of my graphs, I would have in fact gotten parallel lines. They would have never intersected. So that means that's why that says there's no solution. So we call this an inconsistent system. Essentially, they're parallel lines, but the big answer you want to put in your answer box is they have no answer. There's no solution.